So, welcome back again. After a short break, we are here, and let me introduce our next speaker. Um, I'm personally honored to say that lead cinematic programmer from CD Projekt Red, Filip Pierściński, is our guest today. Welcome, Filip.
Hey, hello.
How are you? How was your day today?
Quite fine. I was preparing for this presentation quite hard, so I hope that you will like it.
Yeah, so let me start your presentation. I like this yellow cyberpunk color. Wow, amazing. So, without further ado, stage is yours.
Thank you. Um, Hello, welcome to my presentation. I'm going to talk about our approach to tools, pipelines, and implementations in our latest game. Technology and tools presented in this talk was co-founded within Sectoral Programme GAMEINN, provided by National Center for Research and Development. The name of the project is Cinematic Feel. Comprehensive technology enable a new level of quality in delivering unique cinematic experience in high-end open-world RPG games, including innovative pipeline solutions and custom toolkit. Bit about myself. Several projects that I was working on towards two from the Reality Pump, Witcher Wild Hunt with two expansions, Hearts of Stone and Blood and Wine, and finally Cyberpunk 2077, which is the focus of this talk. Topic of interactive scenes in Cyberpunk 2077 is really vast, and a lot of people were involved in shaping up the design and later on delivering the scenes. I would like to thank all CD Projekt Red developers who participate in the process: cinematic designers, story writers, quest designers, programmers, gameplay designers, QA, all the artists, producers, and others. It's, believe me, really hard to name everyone. Thank you. About the project, Cyberpunk is open world action adventure story set in Night City. Night City is a megapolis obsessed with power, glamour, body modification. In Night City, life is hard and there is no good choices. Every decision has consequence, and to survive, you need to be really hard, really strong. All those extreme emotions, dangerous relationships, and twists are reflected in the cinematics and in the story. So let's see the trailer that contains many scenes and capture the essence of the cinematic feel better than words.
Test of a person's true value. Death. Facing it, staring it down.
Johnny!
I got you.
Pressure's tanking!
It's neurogenic shock. He's dying.
V, you in there?
My head. So what now?
Now, you find out what it is you need to do.
A thing of beauty, I know.
You've never backed down from anything in your life, even when you maybe should have. You go through Night City knowing a stray bullet could end you while hailing a cab. But that's never stopped you from taking action.
You believe you cheated death. It is death that has cheated you.
If you gotta kill, kill. If you gotta burn it all to the
Don't move!
Out of my house! No!
Will never fade away. What you did to me, I know. Somehow I find a way, but I think of beauty.
Would you rather live in peace as Mr. Nobody, or go down for all times in a blaze of glory?
Will never fade away. Will never fade away.
During my talk, I would like to guide you through the interactive cinematics keys aspects. Next, I will show you our toolset for the scenes, how it looks, how it works, and I will use it. And at the end of my talk, I will show our approach to the staging in such big game as Cyberpunk 2077. Cyberpunk is very different from The Witcher 3, and that's we had to come with new approaches. The scenes, of course, was not the exception. So let's go through those key aspects, which illustrates also the differences between those two games. The first aspect, it was also very vocal, is perspective. First-person perspective view is natural choice for immersive story, to showing immersive story. However, it leads to certain complexities. The camera in FPP is difficult to animate, and any error in animation data, later on calculation on those animation data, and later on animation graph state changes are very visible to the player. I want to show you one example how easy it is to break the immersion in FPP view. First, please focus on the left-hand side animation. Watch it for a few seconds. Take your time. Probably you noticed that. Now focus on the right-hand animation for a few seconds. It's very smooth. Have you noticed how irritating was this sudden movement on the camera on the left animation? So you can understand how painful those camera bugs are, how they was problematic for us. And here, what was the problem? The error occurs because the animation didn't load on time. The first frame did not load on time, and animation blending was incorrectly calculated. A very visible example where the tiny problem can break entire sequence. And it's really not important how fluent rest of the stuff is, how the animation on actors are fluent, how the assets are good. Everything is broken. Second aspect, and it's also very important aspect for all our game, is that player is an actor. You can see on this example how one scene can be presented from different perspectives. Player is taking active part of the scene, and because of this, in most cases, it was impossible to use very common smoke and mirror technique to reduce production costs. Player in Cyberpunk can see and also hear much more than in previous CD Projekt games. Third aspect is female or male protagonist. In Cyberpunk, 90% of the scenes came in two variants, one for female V and one for the male V. This increased complexity of the dialogues. Each V lines comes in 2 versions. In many cases, also, there are 2 versions of response. Some scenes must be constructed differently for the female V and differently for the main V. The best examples are, of course, any romance scenes, but it's not only that. We had much more of those examples. Okay, so we already know the key aspects. Now I want to go to the tool set. I will describe our tool and later show how to use it to build scene structure. The heart of our pipeline is scene editor. It consists of 4 main areas: preview viewport, timeline, screenplay, and graph. First, most noticeable is preview viewport. That's where the designer can see scene during the preview sessions and modify the world. Second is the timeline panel with the events like animations, VFX effects, lookouts, dialogue events, and more. Next is a graph with scene and game logic. And the last one, very interesting, is the screenplay with the dialogue lines and dialogue options. I want to show you a few characteristics of the graph. It's directional. What it means that, in practice, it means that signal needs to go from the output of one node and go to the input socket to the another node. Nodes can have many inputs and outputs. On left side we have inputs, on right side we have outputs, and another important property, those sockets do not have type, so you can configure the nodes and connect them in any way. We have possibility of cycles, and this is quite important in the games, RPG games, so you have many options to reuse dialogue lines, but also to reuse whole quest paths. We have 2 types of nodes. It's latent nodes and immediate nodes. Latent nodes hold the signal as long as operation is executed. Immediate are fire and forgot. Additional properties for the latent nodes is that we are able to save to save progress of them and can be cancelled. We have plenty of various nodes for different purposes, but among of them we have 4 exclusive nodes for the scenes. First important node is the section, which is timeline holder. Second one is a choice, which is used to dialogue branching. We have 2 additional specific nodes, but I will be not covering them deep in this presentation. Interrupter manager, and this node control how the scene should behave in case of unaccepted conditions for scene progression. Like, for example, player is exiting the area where the scene is, or for example, the gunfights start. And second one is re-enable section. It's extended version of the section with the ability to play backwards. Also have some additional options to control directly from the player. We are using it in Cyberpunk Braindances. Section is a node specifically dedicated to create time synchronized sequences. On the graph here you can see 3 of them. They are, as you see, connected in very different configuration. What else about the section? Section node have their own timeline, which give designer low-level control over what's happening in the scene. Timeline contains time-placed events, some of which have duration, like animation or dialogue lines. Other are just point events like VFXs, lookouts. Timeline stores those events on tracks, and here you see on the left it's highlighted our tracks. And to indicate the progress, we have two things. One is playhead, it's marked next to the tracks, and on the right top corner a timer where you also can see the progression of the scene. On far right you can see screenplay panel. Screenplay is a section view for dialogue perspective. Also you can consider it as view of the data for the writer. So we supporting many such things that depending on the job, the view of data is a bit different. Now we know how scene editor is constructed. I think that it's time to see what it can do. We will go through the process of creating basic structure of the scene. And I want to reconstruct part of existing scene from Cyberpunk, but don't worry, it will be not big spoiler because I choose one from the beginning. So let's watch a part of this scene from the game. So let's start from creating sandbox environment to start this scene. To create game session in REDengine, we need to game definition. And this is this resource with a small gamepad. To set up it has two parameters. One is reference to the word. I think that I don't have to explain what is it. And second is the quest resource. Quest resource contains graph with the start and the end node. In example above, you can see a scene node between them. A scene node defines how to start scene instance, which is runtime representation of scene resource. Scene assets. This is what you see here is our asset browser. Looks like every scene contains those files. First is scene solution. Is in a editable version of scene optimized for editing purposes, and it's not loaded by the game. It's only for editor. Second is a scene is a resource loaded by the engine during the game session, and it's optimized for the size and the speed. The scene files are creating in the process of compilation of the scene solution file. Compilation process is started manually by the designer. Other files are support files. Prefab is not exclusive file for the scene. It is container for certain slice of the level. It will contain most important elements for the scene, such as a marker, which represents scene origin in the world. We keep it next to the scene file for easier file management. scn-log.json file is export of text sources for purpose of localization, and this file is also creating during compilation process. In screenplay, you can see dialogue lines, and here also you see that I already created a section. So everything is connected. The section have dialogue lines in the screenplay, and section have a timeline, which is filled with dialogue events that correspond to dialogue lines from the screenplay. Worth mentioning parts of the screenplays are section name, and it's very useful because this scene which I showed you, it's simple, so it has only one section, but it can be many, so it's better to have it for faster search. Speaker, which here is Jackie, addressee, which here is player, and dialogue lines. The section timeline is filled with dialogue events that correspond to dialogue lines from the screenplay. Modification of screenplay automatically update the timeline view. The length of dialogue lines are progressively updated. First and preliminary length is calculated based on text itself. Then the length is taken from automatically generated voiceovers, and finally from the records recorded by professional actors. Second note, which is important for the scenes, are choice notes. Choice notes have dialogue options just like sections have a dialogue lines. Dialogue options are also creating in the screenplay. After creating dialog option, a new socket appears on the choice. Here you can see, I know that it's not very clear, but there is two sockets because we here have two choice options, and one is connected to the one end node, this red one, and second one is to this blue end node. Great. We have structure of our scene. Let's play it in scene preview. You will see that it has all elements. It has section, choice, it has actors, dialogue lines, and dialogue options. Only what is missing is VO and the lip sync. Staging will add later during presentation. VO can be generated using Google WaveNet, and lip sync can be generated on top of those generated voiceovers. Both of those processes are offline implemented with help of our infrastructure services. So on this video, you'll see that I'm starting the preview, the playhead is moving, and consequence dialogue events are run, and you see the dialogue lines appearing. After section ends, the signal is going to the choice node, and after 5 seconds, automatically the choice is picked and the signal goes to the red end node. And now we have all basics, so I can go to first description of implementation, and it will be signal distribution mechanism. I'll be using in this presentation diagrams instead of pure code. So here the condition large part of codes are in these rectangles made from dots, function as rectangles made from the dashes. Signal distribution is started from scene state called run. Scene instances in general have many states and it's changing, but here we'll be focused on state run. So state run, like other states, gets floating point delta time from the engine. Delta time is used to increment our internal scene clock. Our internal scene clock is discrete fixed point value in milliseconds for trivial comparison and calculations. Scene clock then is converted to the time window and passed to process token function, where the signal distribution is performed. Some interesting facts about the scene instances. In Cyberpunk, we can have up to 200 active scene instances at once, which can consume maximum 1 milliseconds for all scene instances on the game thread. For any platform, it includes old gens. And we have thread-safe communication with external systems. So it's giving us some flexibility when we want to run our updates. Signal distribution is based on token concept. The main assumption with used tokens was to be able to update entire graph, but selectively. Also to be able to propagate time budgets together with the signal, and also very important to have data locality. Here you can see the simplified main loop, which progresses the signal in scene graphs with using tokens. So before it's run, how the scene instance can start, because it's created, and then what? We are putting signal token on the node. In most cases is start node of the scene. And what means put signal on the node? It means that we are creating signal token object, assign to it node ID, and add it to the array. First operation during the process is that we are changing inactive tokens to active if we can. Purpose of those inactive tokens is to live between frames and to be able to control time budgets. So a good example would be that, for example, you don't want in this particular frame execute some node, but you want to in another frame. So then you are putting inactive instead of active state token, signal token, sorry. A part of signal token nodes, node can generate execution token, which gave permission for the node for execution on the external systems. And also node processing can generate state token to perceive node state between frames or between game sessions. So tokens are generated during node process. We are looping, the loop of signal distribution is executed until we have active tokens. So until we have in our array active tokens, we are looping. When it's empty, we can take another scene instance and do the same, or it's end of our system processing. Interesting facts about the tokens is that we use one size for the tokens, so we can store them in the array, and array are very good for memory locality. And graph state is independent from the graph data, so we can optimize differently the memory for the state and differently for the data. So taking all of that, we could reduce the memory pool for the runtime scene data to 4 megabytes, which is quite good for such big game. We already have a basic structure which would be done by the quest designer normally in the production. Now let's go to the staging, which is done by the cinematic designer. First few terms which I want to know. What is staging? This is how actors are staged or placed at the scene to guide player and get the best possibility image quality, yeah, to have perfect composition. Work, you can considering as a key pose, can be understood as animation which do not contains a lot of motion, and it's placed in some position defined by the staging. Work spots, this is short name for the work resource. Animation between works, I will be calling transitions, and works and transition will be placing on timeline as an events. So let's go and start building the staging and go through the staging process. First, in the section, we need to turn on dedicated timeline track for a jockey. You will see also that there are not only one track, but many sub-tracks, and this is default layout which can be extended. Dedicated track is for organizing events and auto-set references. We have dedicated track. Now I will add change work event, and this event is dedicated to set a work. Parameters to set are the target, so in our case it will be jockey entity, and second parameter is work. I will record that work is an animation or simple pose with certain placement in a scene. To select work, I'm using work picker, and I will set sit to hands on knees work. This will be the name of this work. And as you see, work picker have nice context search, which filtered out work spots library. And we have useful live preview with target entity. About work picker itself, it's using work spot library, which is set of work spots sorted in categories with naming convention, which allowing quick search. Work spot library you can imagine as map view of folders with work resources. I'm showing here two works in common configuration where addition to the idle animation has additive animation played in pseudo-random manner. The purpose of it is to increase variety of animations seen in scenes, and also it makes it more interesting for the player. Okay, so we have set work. I will start the preview. You can see that jockey immediately changed the work from the default work to work from the event. And this default work we are calling idle stand. Despite the fact that it's a point event, jockey perform animation in loop. Work is not a single animation. It's a whole logical AI state of entity. Now transitions. So let's look at the further process of adding works and transitions. I add another change work event, and this time I'm selling transition. Editor automatically deduct what pose was before and suggest the transition that matches. After selecting, also note that work is also auto-selected. This ability to deduct what the state of the actor is before certain moment, combined with proper naming convention, is a big speed gain for designer. Also, on top of that, if you can start preview from any moment of scene graph, then you will have really nice, fast implementation iteration loop. but we cannot afford to record all animations for all combination of transitions between works. It's just physically not possible, and we didn't have budgets for that. So next transition, I need to select manually. I turn off the filter in work picker and search for the best fitting transition to my scene. This balance between pre-record transitions and generic ones is a place where we are searching cut-off production costs. Okay, so we have all poses. Let's see how the scene looks like with the structure, works, and transitions in previous session. Again, we starting the preview. You will see that similar like on the previous video, we are moving the playhead and the dialogue lines appear, but also the corresponding transitions are run, and Jackie is changing also the poses in between. So this is very important, that this possibility to play scene or part of the scene just after make the changes to the scene is extreme boost in implementation time. So now we are ready to go to the second implementation, which I want to show, is events processing and execution. We already know what are the events and where they are in editor. Internally, timeline track do not exist, but I keep them here for easier understanding of the concept. Implementation of the events contains ID, start time type, and per type dedicated parameters. During section process, section get time budget, like any node, and this budget is transformed into time window, which, and here are two important properties, on left is inclusive, on the right side is non-inclusive. What is outside of the time window was executed or will be executed in the future. But what we understand by inclusive and non-inclusive sides of the time window. Here you can see on the slide that one event, its start time is equal to the start time of the time window, and in this frame we will execute this event. But we have also second event, which start time of this event, point event, is equal to end event of time window. In such case, this event in this frame will be not executed and will be executed in the next frame. The event processing begins with determining the position of the event cursor based on time window. And then we iterate through events until we get to the event which is not contained by the time window. It's not overlap. We're creating action parts during this processing of events. About action parts in the moment. For now, let's focus that we can generate different action parts depending on activity of the event. And that's activity of the event is determined how time window overlap the event. If the time window contains the beginning of the event, it's start activity. If the window overlap middle part of the event, then it's regular activity. And if the end is covered, it's end activity. The individual action parts are arranged by action key in such a way that after sorting, the action parts will be grouped by the type, and action part with the highest priority will be performed first. Combiner is additional parameter to sort action part within a type. So combiner can be, for example, target ID, on which we will perform execution. So we can, for example, first do action part for first entity, then for the second and the third. I think that is a good moment to explain why we are creating those actions and action parts and not executing directly from the events. Execution process should be optimized with taking into account speed, dependency resolving, and external system characteristics. To meet those requirements, we use actions which give us separation and flexibility. Action and action parts, in contrast to events, are created in runtime, have good sorting capabilities, and because they are created in runtime, are aware about dependencies within scene instances. Okay, so we pass the part with the processing, now execution. The execution of the operation begins with the sorting of action parts based on action keys, those which we were talking about on the previous slide. Then the action parts are added to the action. The relationship between action and action part is that action contains execution code, which use action parts as a parameters. Finally, the actions are performed, which may result as execution on external system or composer. Composer is a module responsible for distributing operation between different scene instances on the same target. For example, if you have few scenes running at the same time and they are accessing player, so we need some layer which will be detecting the conflicts or deciding what should be first and what should be second. At the end, I want to show you how the preview session works in the scale, and I will run the preview session of the final version of the scene with night city loaded, VOs, lip sync, and post processes. I know that maybe you are not hearing the voice, but sorry, I will not fix right now, but you will see much more than on the previous session for sure. So it looks pretty identical to what you see in game. Yeah, so you can pause, change the camera. Yeah, player do not have head. It's pretty funny. Yeah, we can go back to FPP camera. Okay, let's go to summary. So after my presentation, you know that first-person perspective was an important part when we are designing and implementing many things in the toolset. And you know that female and male protagonist is not just parameter in the game setting statistics. It's important characteristic when you're creating a scene system. I showed you scene editor, and I did for you scene structure with the scene staging in practice. We went through the signal distribution, which use tokens, and learn how it works and that is quite light implementation. At the end, we decompose event execution process with use of actions. Thank you for being with me. I hope that you found something interesting for you in my presentation and your future games can benefit from it. And having this opportunity, I won't say that we are hiring. So if you are interested in working with us, for example, on such interactive syntech, please reach out to us. Stay healthy, stay safe. Thank you.
Thank you, Philippe. That was an amazing session. I was looking at these videos, and this example with the right hand was really inspiring because I was looking on the right side of the screen where the smooth hand passing by, and the left side of the screen with this quick hand. And wow, that's an amazing job you're doing. I can see the small details that increase the final quality of the game.
Yeah, it's often, I couldn't sleep because of those bugs, and they are really stressful. I mean it. I think that you can compare it, and probably there is some people who was working on VR, and there is also very important this FPP and to not, doing such different things with the camera because you can get motion sickness. And I literally, when I was fixing those bugs and polishing the stuff, it was very stressful. Yeah, and you couldn't, say no, it's good enough. No, it needs to be smooth. If it will be not smooth, the whole sequence is broken. And yeah, it's very important.
Yeah, I can relate. When there's a small unsmoothness that that there it is, and that you can deal with it, and you can't just forget about it. Yeah, I totally understand that, and thank you for what you are doing, because I believe that perfectionists like you add significant value to our products.
Thank you very much.
So thank you for joining us today. Thank you for your amazing presentation. So guys, please rate this presentation in Pine. Press the like buttons on YouTube if you're watching this on YouTube. And thanks for joining us today. Thank Philippe, and hope to see you next time.
Thank you very much. See ya.
Bye.